nervous system is further divided into your somatic nervous system that controls voluntary movement, right? So moving your muscles, which is under your voluntary control. Then there's the autonomic nervous system, which is what we're going to look at today. And that is everything that you're not thinking about doing. Your heart rate, your respiratory rate, right? Your GI, your gastrointestinal system. Those involuntary actions that are being carried out throughout the body that you're not consciously deciding upon or thinking about. Okay? Now, within the autonomic nervous system, it's further divided into two, what I like to call equal and opposite forces, the parasympathetic system and the sympathetic system. Okay, everyone with me so far? So we have the nervous system, the peripheral nervous system, the autonomic and somatic, and the autonomic is further divided into two forces which keep everything in balance, the sympathetic and parasympathetic. Now, before we actually get into, these are our learning objectives for today, but before we get into the content, I want to give you two scenarios, which are going to serve as the backdrop for you to understand when I say parasympathetic, what I mean in terms of the body functions, when I say sympathetic, what I mean in terms of the body functions. So I want you to sort of, in your own mind, imagine that you're actually in these two scenarios. So the first scenario is you're in a strange neighborhood, right? And you come upon a yard that has a big dog in it, and you automatically feel a shift in your body. All right, so you feel something shift when you see the sight of these two large dogs. So, okay, you think maybe if you turn away, try to walk away slowly, you can avoid any sort of danger. And you turn to walk away, and the dogs start chasing you. All right, now you're in this strange neighborhood, and you're being pursued by these two large dogs. Think about what your body is going through. All right, your respiratory rate is probably through the roof. Your heart is pounding out of your chest. In a minute's notice, all of this shit happens. All right, blood is being shunted away from your gastrointestinal system and to your skeletal muscles. Why? Because you don't need to be resting food at this time. You need to be actively moving your muscles to get away from this source of threat. Right? What mode are you in at this point? This is called fight or flight. Anytime you perceive danger or any sort of threat, be it real or perceived, your body will kick into this fight or flight mode. And this is the influence of the sympathetic nervous system. Now, a very different, very opposite scenario is, let's say it's Thanksgiving. Thanksgiving is coming up shortly. And you're home, you had a large meal, you're sitting back, relaxed, probably your favorite comfort food, whatever it is. You're stuffed, you're getting a little tired, a little drowsy, maybe you're reading a book, right? And everything is sort of slowed down at this point. You're not expending energy, instead you're storing energy. You're resting, you're recuperating, and your body's actively digesting. Right? This is very different from the scenario we just described. This is your rest and digest mode. Okay? And in this scenario, your body is trying to recuperate, trying to restore energy, right? Trying to digest food. Blood is being shunted away from your skeletal muscles, because you're not using them, to your digestive organs. Your heart rate, nice and slow, nice and steady. Your respiratory rate, again, nice and slow, nice and stable. And this is the influence of the parasympathetic system. Okay? So I want you to bear those two scenarios in mind as we go through today what each of the divisions of the autonomic nervous system does to your body. What's the influence? Okay? Now, the first objective we have is to really describe the anatomy of the nervous system. Okay? But I want you to first, the second is described, bear in mind that there's these two forces acting together in what we call comparative secrecy. And all that comparative secrecy means is that there's this involuntary control this involuntary sort of tug of war, right? You don't have one overtaking the other. They're both in this delicate balance to keep things stable. If you lost the activity of your parasympathetic system, your blood pressure would skyrocket dangerously. If you lost the influence of your sympathetic system, your blood pressure would drop dangerously low. So both of them are needed to keep things in balance. And as an effect, they're essential to homeostasis. Right? We should really talk about homeostasis a little bit. That concept of keeping everything in balance in the body. Okay? So what we're also mentioning here is that they're antagonistic to one another. So if the parasympathetic speeds up heart rate, the parasympathetic slows down heart rate, sympathetic speeds it up. So they're antagonizing each other. Any questions so far? Everyone still with me? So this image gives you an overview of the entire autonomic nervous system. And I know it looks a little bit jumbled, a little confusing, but it's a schematic representation of how both of these divisions, so sympathetic on the left and parasympathetic on the right, influence all of these various body organs. Right? So the body functions that we talked about earlier. So you have your lacrimal glands, which give you tears, the salivary glands, which give you oral secretions. Right? You have your heart, your heart, which is your heart rate. Your lungs controls your respiratory rate. You have all the digestive organs, your bladder function, and then your genitalia. So all of these are being acted upon by both forces. And whenever the body is in an external condition which requires it, such as a perceived threat, the sympathetic will sort of kick up and take over dominance. Right? But the parasympathetic is also having an influence. Now, what's important in this image is to understand the area of the spinal cord which gives rise to the sympathetic fibers. So the spinal segments are T1 to L2. And those specific segments of the spinal cord give rise to the fibers that are the sympathetic nervous system, right? Whereas the parasympathetic nervous system, the fibers are going to be the brainstem, right? So cranial nerve 3, 7, 9, and 10. And we're going to look at those individually coming up, as well as S2, S3, S4. Okay, so for that reason, the sympathetic system is sometimes called the thoracolumbar outflow. The thoracolumbar outflow, and the parasympathetic system is sometimes called the craniosacral outflow. Right? The craniosacral outflow. And again, all of that means is that these spinal segments give rise to the fibers that innervate the sympathetic system, and these fibers, right, from the brainstem, as well as these spinal segments, give rise to the fibers that innervate the parasympathetic. Now, when we go through and look at the anatomy of each of the systems, so the sympathetic versus parasympathetic, we'll see some differences, such as the nerves of the sympathetic system are going to be shorter, the preganglionic nerves are going to be shorter, whereas it's going to be longer on the parasympathetic. So as we go through, we'll look more closely at those differences between both. Okay. Another thing worth mentioning on this slide is that this structure right here, this structure which is very closely associated with the spinal cord, so in actuality it's called the sympathetic chain. And if you were to take the human body, right, take everything out of the abdominal cavity and look down into the floor of the abdominal cavity, you see the sympathetic chain running alongside the tuber column. And all of the sympathetic chain is a collection of these ganglia, right? Collection of these ganglia. And we'll talk more about it. But just bear in mind that the sympathetic system, right, is T1 to L2. It's closely associated with the sympathetic chain, and the parasympathetic system is your craniosacral. Cranial nerves 3, 7, 9, and 10, S2, S3, S4. Any questions so far? All right. Now, we're going to talk about the connection from the spinal cord to each of those effector organs. So how do those neurons communicate the signal from the spinal cord to, let's say, the heart? You want to see that part. There are two connecting neurons. There's a preganglionic neuron and there's a postganglionic neuron. And you would have sort of looked at this with Dr. Eder, as you mentioned, those two neurons that speak to each other at a ganglia. Right? In the case of the autonomic system, they call preganglionic and postganglionic. And they're going to communicate at an autonomic ganglia, okay, which is sometimes called an intrinsic neuron if you're looking at the gastrointestinal system. I'm going to draw that out so it makes a little bit more sense. All right, so we have our central nervous system, peripheral nervous system. Okay. Now we have the spinal cord in this region. Now bear in mind, this can also be, if it's the sympathetic, it's going to be T1 to L2, but if it's the parasympathetic, what is it going to be? Right, it's going to be the brain stem, cranial nerve 3, 7, 9, 10, or S2, S3, S4. Remember that? Thoracolumbar for the sympathetic, craniosacral for the parasympathetic. Right? We have one neuron that's going to cross into the peripheral nervous system, and it's going to synapse with another neuron that's going to go to the effector tissue. Okay? Now, the area where both of these neurons speak to one another is called a ganglia. And all that a ganglia really is a collection of cell bodies outside of the central nervous system. So in the case of the autonomic nervous system, this is called an autonomic ganglia. Right? And if you remember the sympathetic chain that I pointed out earlier, it's a connection of all of these autonomic ganglia. So if you think of them as pearls on a string, running right down the length of the vertebral column, all of the autonomic ganglia line up together to form the sympathetic chain, right? T1 to L2. Now the first neuron that crosses from the spinal cord to meet at the ganglia is called a preganglionic neuron, preganglionic. Right? And the second connecting neuron, which is actually going to speak to the effector tissue, is called your postganglionic neuron. Does that make sense so far? All right, so we have two neurons. One is leaving the spinal cord. It's going to synapse at a ganglia. This is where they're going to communicate or speak to each other. That's your preganglionic neuron. That's going to leave the autonomic ganglia, and it's going to speak to the effector tissue, which again can be heart. This can be your heart tissue, your heart muscle. This can be smooth muscle. This can be glands, or it can be fat tissue. These are those various effector tissues that we saw in the middle of that image. Okay, now what we'll see, again, I'm pointing out these now, but we'll see them more closely when we get to each of the systems. There's a difference in the length of these neurons in the sympathetic system versus the parasympathetic system. All right, everyone with me so far? So we're going to bear in mind that we have two connecting neurons, our preganglionic and our postganglionic neuron. Okay. So this slide is just pointing out some of those effector organs or effective tissues that we just spoke about. Again, it can be a cardiac muscle, it can be glands, salivary glands, lateral glands, it can be fat tissue, or it can be smooth muscle. You have smooth muscle everywhere. Smooth muscle in your respiratory area, smooth muscle in your blood vessels. Right, so these are all the effector organs of autonomic nervous system. We'll see when we get to somatic that the effector organ of the somatic system is skeletal muscle. All right, so this is that image that I just drew. Again, you have your cell body leaving the central nervous system. and your preganglionic neuron. Then the synapse at the ganglia to a second neuron, which is called a postganglionic neuron, and that is when the synapse comes to sympathetic. Right? And again, these autonomic ganglia are going to line up together to form the sympathetic.